Hey guys, so today we are starting Unit 2 and it's going to focus on equations and inequalities, writing and solving. Today we're going to focus solely on equations and writing equations from real world situations. We're not going to solve the equations, we're just going to focus on writing them. Okay, so in order to do so, we need to understand a little bit of the vocabulary associated with it and the progression of what you already know. So here, this is the progression through the years. In elementary school, you started off with just numerical expressions like 7 plus 5 or 8 minus 4. Then you move slowly from in like 6th and 7th grade to algebraic expressions where we involved that variable. So for example, 6x minus 4 or just 3x or negative 9 times or negative 9w minus 2. Okay. And now, for our equations in 8th grade, we're going to take two algebraic expressions and set them equal to one another. So for example, this one right here, this 4 minus 3y equals 2y minus 8. Okay, so we took two expressions and we set them equal to one another with the variable on both sides. And that actually covers our topic today. So first things first, we need to know a few vocabulary terms, and so that way we can move on and understand the parts of an equation. So first things first, it talks about the terms. A term could be a constant, a variable, or a coefficient with a variable together. Terms are separated by plus and minus signs, and it gives us an example. It says 8w plus 4 minus w. So if I'm looking at this one, this expression has three terms. The first term is 8w, okay, a coefficient with a variable. The second term is a constant, which is 4. And last but not least, the third term is just a variable by itself, okay? Now, if you don't remember, a coefficient, the number combined with the variable in a term by multiplication, okay? Or it could also be division. Multiplication is probably more likely what you're going to see with most of these. Okay, so it says an example, circle the coefficients in the expression. So again, a coefficient is the number with the variable held together by either multiplication or division. So there are, in this equation, there are two coefficients, 14 and 3. Both of them are attached to x by multiplication. If it were division, it would be something maybe like x divided by 4, or you could even see 3/5 x. Okay, so those are examples. Constant. A constant is a number that stands alone in an expression, and it has no variable. Okay, so the example 5f plus 4, the constant here would be 4 because it's a number that's standing alone. It doesn't have a variable, okay, or anything attached to it. It's just by itself. An expression, again, an expression is a mathematical statement that contains a group of numbers or a group of terms, okay, and operations. All right, so it says an expression does not have an equal sign. Okay, so look at the example 8x plus 1. There is no equal signs, it's just an expression. We have a term, one term here, and one term here, and then it's held together by an operation. All right, an equation. An equation is a mathematical statement that sets two things, that two things are equal. Sorry guys, I think that was a typo in that sentence. An equation has an equal sign, okay, and it says that the values on the left is the same as the values on the right. And the example they give is here is a typo. A better example, let me mark this out and give you an example. So for example, we might see something like 4x plus 3 is the same as or equal to 5 minus 2x. Okay, where these two expressions are set equal to one another with this equal sign. Okay, and again, on this part, we're not going to be asked to solve. Here, we're just writing the equations. All right, so if I move too fast for the vocabulary, I did put a link in the homepage where it says vocabulary flashcards. Feel free to click on that, go through those vocabulary words, and identify parts of the equation. All right, so moving on. Okay, so again, just a simple way where our equation is going to look like now in 8th grade. We're going to have two parts of our equal sign, again, but it's made up of two expressions. Okay, here's expression number 1. Then it is set equal, or is the same as expression number 2. Okay, so we have a left side and we have a right side. We have part 1 and part 2 set equal to one another with this equal sign. Okay, this is the more classic way you're going to see it. You might see it here this way, where we have 5 plus 3z equals 6z minus 2 to the power of 3. So here we would have expression number 1, or we have the left side, compared to expression number 2, which is the right side, and they're set equal to one another. Another version would be this here, where we have the left side, or part 1 is 3/5 times y. The right part is part 2, or even 2, y minus 2/10. Again, expression 1 here, expression 2 here, set equal using the equal sign, representing that they're the same. Okay, so let's get down to business. How would we write these when given word problems, right? Okay, so it says the word problem will talk about two separate events, again, two separate expressions. You will have to create two separate expressions for each event and then set them equal, okay, equal to each other using the equal sign. And so I kind of put in this, I guess you can call it like a template of how I make it a little easier to write these equations, and that way it's easier to visualize and see. All right, so let's move on to example 1. Let's see how this works. Okay, so example number 1 says 2 less than 3 times a number is the same as the number plus 10. So first thing I like to do, guys, is I like to identify the two separate parts. And I can do that by easily finding where it says is the same as. I know that if I find is the same as, or equal, or equivalent, this is where my equal sign is going to be. So then it separates my scenario into two parts. Part 1 here, okay, or event 1, and then part 2 here. Okay, and in our little table, I've broken it up just like that. So let's look at part 1. It says 2 less than 3 times a number. Well, in order for something to be less than something, there has to be something for it to be taken away from. So we want to focus on this this part here first, and we know that that needs to be first in order for the 2 less than part to happen. So let's look at it. It says 3 times a number. Do we know the number? Does it tell us what number it's talking about? No. So here, this is where our variable is. Okay. And then it says 3 times. Okay, 3 times. Now, again, that means multiplication. So we can write, that means 3x. Okay, so I'm going to write that a little lower here. So I have 3x. And now I can go back and look at this 2 less than. Less than means minus. So 3x minus 2 for our first part is the same as, let's look at our second part, and this side's a little bit easier, the number plus 10. All right, now, do we know what number they're talking about? No. Same as over here, but if you notice, it's the same, a number and the number, meaning they're the same variable. So x, and then it's a little bit easier here, you can see this plus 10 plus 10. So now I have expression number 1, expression number 2, and I can set them equal to one another. So 3x minus 2 is equal to x plus 10. All right, next example. A number increased by 4 is the same as 19 minus 2 times the number. So again, I want to separate them first into their two events. So I'm going to find this is the same as, because I know that that means they're equal. So our first part, a number increased by 4. So a number, again, that's our variable. Increased means addition by 4. Okay? Example number, or part 2, or to the right side, 19 minus 2 times the number. Well, it's very simple. 19 minus 2 times a number. Okay, so there's our variable, that number. We don't know the number, but we know we're going to multiply it by 2. So 2x. And then lastly, we just set them equal to one another. X plus 4 is equal to, or is the same as 19 minus 2x. All right. For example number 3, go ahead and pause the video. Go ahead and see if you can write this equation and then come back and check to see if you're correct. Okay guys, so hopefully you paused the video and worked example number 3 out. I'm going to go through this to make sure you got it correct. Again, I'm going to identify where my equal sign is going to be, is the same as. And now I have the two parts, part 1 on the left, part 2 on the right. Okay, so on the left it says 20 less than 8 times a number. So again, 20 less than, and if it's less than something, I have to start with something first. So here I'm going to start with this 8 times a number. Again, I don't know the number, that's my variable, but it's held together by multiplication. So 8x, and then 20 less than 8 times, so I know I'm going to subtract 20. Is the same as, if we look on the right side, 15 more than the number. Okay, well, again, the number, we don't know. That's our variable. But we do know 15 more than, hopefully you thought of the operation addition. And so this one should have been 15 plus x. And then we could set them equal to one another. 8x minus 20 is equal to 15 plus x. All right, hopefully you got that correct. Now let's move on to a bit of more complicated math problems, which is kind of what we'll see on exams and things like that, word problems, right? So real world problems. Okay, so again, the steps are to identify the variable, write expression 1, expression 2, and then set them equal to one another. So, example number 1. Andy's rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? Okay, there's our key word, the same. It wants to know when will the amount be the same for both companies. Okay, so how many days would it take for both companies to charge the same amount? So that's where our equal comes into play. Now we just need to look at our two parts. Here we have Andy's rental car, and then we have Buddy's rental car. So I'm going to use Andy as event 1, just because they put his name first. All right, so we have Andy, and then we have Buddy. All right, so Andy's rental car charges an initial fee of $20. Initial fee means this is what you're going to get charged automatically no matter how many days you actually rent the car. Okay, so that's what we're starting with. Then it says plus an additional $30 per day to rent. Now our variable, do we know how many days someone is going to rent a car? Every customer is going to be different. Someone might need the car for only 2 days. Someone might need the car for 10 days. So that part is our variable, the per day, the number of days that someone would rent a car. So here, when we're talking about our variable, we want to think per day because each situation is going to be different for every person. Okay, so we want to write an equation that could be used for any number of days. All right, so we got our 20 plus now our initial fee of $20. Now we're looking at this second part, an additional $30 per day. We said per day is the variable. Per can also be associated with multiplication. So plus 30x. And I get that plus from where it says plus. Okay, let's look at Buddy. Buddy's rental car charges an initial fee of $36. So we're starting here with Buddy. Buddy starts off with $36 plus an additional $28 per day. Okay, so that's our variable, 28x. Okay, then it says for what number of days is the total cost charged by the companies the same, meaning they want us to set it equal to one another. So 20 plus 30x is equal to 36 plus 28x, and that would be our equation for this scenario. All right, vocabulary is key, guys. Make sure you're understanding what the words associated with the operations are. Okay, let's do another example. Example number 2. A water tank holds 256 gallons, but is leaking at a rate of 3 gallons per week. A second water tank holds 384 gallons, but is leaking at a rate of 5 gallons per week. After how many weeks will the amount of water in the two tanks be the same? So again, we're looking for when the amount of water is going to be the same. So again, we know we're going to set our equations equal to one another, and there's two parts. There's water tank 1, okay, and then there's water tank 2. All right, so let's look at water tank 1 first. Okay, it says it holds 256 gallons. Well, we know that. Okay, that's what it's giving us. We know that information. But is leaking at a rate of 3 gallons per week. So leaking, okay, obviously that means it's losing or something is being taken away, and we can associate that with subtraction. And then at a rate of 3 gallons per week. Okay, so it doesn't tell us how many weeks, it just says per week. So that's our variable. Okay, that's what is changing, per week. All right, that's the unknown. But since it says 3 gallons per week, we know that we're multiplying. So this would be 3x. All right, tank number 2. Second water tank holds 384 gallons. So we know we're starting with 384. Then it says is leaking at a rate. All right, so again, this one is also leaking. So it's losing water, subtraction, at a rate of 5 gallons per week. So that's our variable. It doesn't tell us how many weeks. So 5x. And then it says after how many weeks will the amount of water in the tanks be the same. So then we know we're just going to set these equal to one another. So 256 minus 3x is equal to 384 minus 5x. All right, guys, the last example, I want you to go ahead and try it on your own and go ahead and leave your equation in the discussion. Okay, again, so make sure that you're understanding and reading the situations carefully and identifying the two separate parts so that way you can set them equal to one another. Okay, again, feel free to watch this video as many times as you need to, and go ahead and enter your example number 3 in the discussion. Okay, I put an exit ticket also for today. This is what it looks like. So again, you're just asked to write the equation for each of these scenarios, and where it says type the equation here, you're just going to type it in there and then press submit. So again, back to the example number 3, make sure you put this equation in the discussion. Hopefully this video helps, and hopefully I see you at a live session at 9:30 and 2, and have a great day.